Hi guys, welcome back to the channel. I hope you all are doing good. So in this video, we will solve another problem on dynamic programming. This is called optimal strategy for a game. So let us read the problem statement. Pause the video and read it. You are given an array of A of size n and it is of even length. We will see why it is even length, why only even length. The elements of the array represent value of coins. In each turn, a player can either pick last or the first coin from the row, remove it permanently, and take that value of the coin. So he will add it to his sum, whichever player, either player 1 or 2. Whenever he removes a coin, it will add to his total count. And we need to determine maximum possible value of money that we can get. We are player 1 and we are going first. We play first. Okay, so we are player 1 and both players play optimally. Now this statement is also important to understand. So let us take the test case example and see what is exactly happening. So if my array, coin array is 5, 3, 7, 10, then so player 1 and player 2, we are player 1. Our objective is to maximize our total count. Actually, both player 1 and player 2 objective is that only. But how player 2 will play, let us see that. But before that, how will we play? We will obviously take whichever is maximum because we are starting first. Whichever is maximum in the last or the first among those two, we will take that. We will take 10. So it will be 5, 3, 7 remaining. We have taken 10. So player 1 has a value 10. Okay. Now player 2's turn. How will player 2 play? Actually, player 2 will play in such a way that in the next turn, we will get a smaller value. We should get a minimum value. That means if player 2, suppose player 2 will take this coin. Suppose player 2 has taken 5, then remaining array is this much. Now out of remaining these two, obviously we will take 7. Another option for player 2 is instead of taking 5, let him take 7. So in our next turn, player 1 next turn, this much will be there. Out of these two, I will choose 5. So instead of getting 7, player 2 will play in such a way that I get 5. So instead of getting a total of 17, I will get a total of 15. This is the maximum possible total I will get. This is what it means by when they say both players will play optimally. So in this case, it was very evident that, okay, because 7 is greater than 5, player 2 will take, but it is not always the case, right? It is not always the case. What I want you to understand is player 2 will pick in such a way that in player 1's next turn, player 1 will get minimum value, will get lesser value. So he has to pick in that way. What does it actually mean? Let us take a general example. Let us generalize this. So let us say we have an array, okay? We have an array, any random array we have. Okay, this is our array of coins. Now, if I take any subarray, if I take suppose any subarray a of I to j, if I take any subarray, then what can be the best possible answer for this subarray? So if I consider any subarray, there are two things that are going to be. They have two options. Just consider any subarray starting from index I ending at index j. Starting where? Index I and index j. First of all, we should check if this is a valid subarray. What does it mean valid subarray? I should be less than or equal to j. If j is greater than I, or sorry, yeah, j is greater than I. How is it going to be valid? It is not going to be a valid subarray, right? So what we will do is, if we consider any valid subarray, right, then we have two options. What is the option one we have? Option one is we pick the ith element, which means we pick the first element of the of that subarray. So to visualize, I is here, j is here, any random subarray, we take the first element. Now when we pick the first element, what is the remaining part? Remaining part will be a subarray starting from index I plus 1 to j, because we have taken the ith element. Now this is the remaining part. How will player 2 play? Player 2 will play in such a way that, as we discussed, we should get minimum. In our turn, in our next turn, we should get minimum. So player 2 will play in such a way that we should get minimum of I plus 2 j or I plus 1 j minus 1. Now what is this I plus 2 j, I plus j, I plus 1 j minus 1? See, when we played first, we took ith element. So what is the remaining subarray? I plus 1 j, this much. Now player 2 has two options. Either he picks the I plus 1th element. When player 2 will pick I plus 1th element, that element will be gone. So remaining array will start from I plus 2. Sorry, if player 2 picks with I plus 1th element, then remaining array will be I plus 2 to j. So then player 1, that is us, we will get an option to pick from I plus 2th element to jth element. Or if suppose player 2 has to make an option like this, he will pick the jth element. If player 2 picks the jth element, then for player 1, what is remaining? I plus 1 to j minus 1. That much subarray will be remaining, right? That much portion will be remaining. So player 2 will pick in such a way that we get minimum of these two. We are only considered about our score, that is player 1 score. So this is the case. This is the first option, that is player 2 will pick the ith element. Now what is second option? Player 2 can pick the jth element also. So sorry, player 1 will pick the jth element first. So see, this a of I that I've written is our move. A of j we have written is our move. Now plus whatever we are writing here, right? Plus whatever we are writing, that will be how player 2 will pick. So suppose our second option is we pick the jth element, we pick the last element. When we pick the last element, our array reduces to I to j minus 1 because we have picked the jth element. Now what will how will player 2 play? Now player 2 has two options. Either he picks the ith element. When he picks the ith element, remaining part for player 1 is I plus 1 to j minus 1. Or player 2 will pick the j minus 1th element. So remaining will be j minus 2, I to j minus 2. So we actually have minimum of j minus 2. We have minimum of these two options, I to j minus 2 or I plus 1 to j minus 1. So like this, it is actually what is happening. It is a recursive solution. It will keep recurring. And where will our answer be? Basically, we are given this array, right? Our array, we considered a subarray I to j. But when we consider the entire array, I will be equal to 0 and j will be equal to n minus 1. We are considering the entire array. So starting will be 0, ending will be j minus 1. So this was the recursive, this thing. Like how do we solve it recursively? Now how to optimize it? We can memoize it, right? We can store all the values in a DP table and we don't have to compute the values that are already computed. So what we will do is, let us suppose we will consider, let us take the example 5, 3, 7, 10, okay? And let us draw our DP table. What is our DP table going to be in this case? It is going to be the index I and j, in indices I and j to get the subarray ij. To get that subarray ij, it is going to be the DP table. So index values are 0 to n minus 1. It can be 0 to n minus 1. I can also be 0 to n minus 1. J can also be. I think in the beginning I told what is a valid subarray. Valid subarray is when I is less than or equal to j. So in this table, we are considering I as the row. Remember that I is the row and j is the column. So tell me, for a valid subarray or for invalid subarray, which are the cells which are going to have invalid subarray? Let us consider this cell. This cell, we are saying that I is equal to 1 and j is equal to 0. Is I less than or equal to j? No, this is not a valid subarray only. When it is not a valid subarray, fill all those values with 0. So you can see that the lower triangle of the DP matrix, it is going to be an n cross n matrix, right? There are n options for I, n options for j, but whatever is valid, we should consider. First, fill the DP table like this. I mean, in the recursive solution, we don't have we don't have to explicitly do this like as the first step or anything. But yeah, I mean, what I'm trying to say is in the recursive solution, we will do it in a different way, but we don't have to this thing do it like how we were doing for the previous problems like knapsack and all, where we were initializing and then starting, not the top down, right? But still, just understand that for finding the invalid subarray, we just have to have this condition that a valid subarray is I less than or equal to j, index value. So all these values are 0. Actually, not this one. This is main diagonal. Now consider the main diagonal. For main diagonal, what are we saying? We are saying for the main diagonal, I is equal to j, which means we have a subarray I comma I. Essentially, if I is equal to j, our subarray is I comma I, which means our subarray has only one element. When our subarray has one element only player one will pick. Like when we pick it, that's all. So all these values, right? These diagonal values, it will be A of I, as I is equal to j. So if I fill it, it will be 5, 3, 7, 10. Now all these upper triangle values we have to fill. So how will this value be filled? For this value, what will be the answer? Actually, where will our answer be? Our answer will be in this cell. Why this cell? Because in this cell, j is equal to n minus 1 and I is equal to 0. So that is what we want, right? Our array is starting from 0 and ending at n minus 1. So best possible answer for this array only we want. So our answer will be over here. So we have to basically fill, but if you are able to understand that, it will be difficult for us to keep a track of whether the index value is valid or not, as we have to check for different subarrays. We also have to check if index value, it should not happen that we are checking somewhere outside this matrix. So over here, I feel the recursive memoization solution is much better. So I will try to code in that way only, because see, for this value, what all cases will be there as discussed. So there will be two options again, right? If I pick the ith element, then player 2 will play in such a way that I'll get the minimum of I plus 2j or I plus 1 j minus 1. Now this I plus 2 j minus 1 index values, we have to keep verifying that it is valid, that is, it is inside this matrix, the index values. So that becomes a little tedious if you just if you don't use the recursive part. In the recursive solution, you can easily do it. So let me code it now. I hope you're able to understand what is exactly going to happen. If you want to fill this table, you fill this table, or if you want me to fill it now, fine, I can fill that now. So 0, 0, 0, 0, 0, 0, 5, 3, 7, 10. Now for this value, what is it going to be? If I say A of I plus, now minimum of what? This is first option, minimum of I plus 2 j, that is 0, or I plus 1 j minus 1, which is 0. So it is going to be, what is a of I? What is I here in this cell? I is 0. So a of I is 5. So one option is 5. What is the second option? I take the jth element. What is jth element? 3 plus minimum of I j minus 2. So j minus 2 is nowhere there. See, over here if we are, where is j minus 2? Minus 2 is not there, right? So that is the reason why we need to be careful about where we are checking. We always have to keep a track of which is the valid subarray. So it's okay, like you just try to fill this table. It will make the video too lengthy, but I hope you have understood. It is very basic. Only 2 cases are there. So when I'm coding, I will tell you. So let me code now. So let us take DP array. So 2-dimensional array, and I'm taking 1000 because max values is that much only. Actually, I'll take 1001. Let me initialize the DP with -1. Why -1? Because I will just have to check if that particular cell has already been checked or not. So initially no cell is checked. So we have to process all the cells, and then we will say return solve DP an 0 n minus 1. What is this 0 n minus 1? It is index I and index j. So we want the answer for that only, right? Our array 0 to n minus 1, you want answer for that only. So yeah, there are different ways of passing a 2D array to function. You can check that out. You can pass it to through pointers also. I just took a max value, and you need to give column value, at least column. Otherwise, you won't get the correct answer. Okay, so now first condition is checking for valid subarray. And remember, see, I am telling I is in the row. I is row and j is column. So if I is greater than j, then it is an invalid subarray. So let us store 0 in that cell, and we will return that value. We will store 0 and return that value. That is what this statement means. Now, if I is equal to j, then there is only one element in the subarray that we are considering. So let dp of ij be equal to a of I only. So what is this? This is for checking a valid subarray, and this is for the case when subarray has only one element. Okay, basically in this problem, the entire array we're breaking into subarrays and trying to find the best possible answer for each subarray, and then getting the best possible answer for the entire array. Now, actually, let us write this. If now we will check if dp of ij is not computed already. If it is not equal to -1, then it is computed. The value is already found. When the value is already found, we'll return that value. We don't have to do anything else because that value is already found, right? Now we have two options. What is our first option? Our first option is pick the first element. So let us say pick first is equal to, so we pick ith element. So first and last means I and j here, okay? Like index wise. So we pick the first element. If we pick the first element, then how will player 2 play? He will play in such a way that in our next element we will get minimum of, now see, I am passing what index value, I plus 2j or minimum of I plus 1 j minus 1. So this is when we pick the first element. Suppose we pick the last element. If we pick the last element, then how will player 2 play? He will play in such a way that we get minimum in our next turn. So what is the minimum going to be? Minimum of these two options. I j minus 2, which means player 2 pick the j minus 1th element, or I plus 1 j minus 1, which means player 2 pick the ith element. Let us store the best out of these two. So let us say we will return this value, and it is going to be maximum of pick first or pick last. Notice that the final value that will be returned is going to be 0 and n only. It will be dp of 0 and n minus 1, not n, sorry, n minus 1, which means what? All the recursive solutions will happen, and finally in this cell, the final value that will be stored will eventually be this 0 and n minus 1, and that will be returned in our answer, the required answer. So what is, like, if you do this statement, what does it mean? It will compute this value first, it will store it in the dp table and return the stored value. So basically we are optimizing, right? So let us see if we get error. So we get the correct answer, and this was the solution to the problem. Basically, if you need more understanding, you take examples and dry run it. Basic idea is this much only. If you have to know how the player 2 will play, you just need to know these two lines. If you know this much, you can try for different examples and verify that it is correct. So this was an easy problem, and I hope you're able to understand. If you like the explanation, hit the like button, share it with all your friends as much as possible, subscribe to the channel, it will motivate me. Until then, take care, stay safe, keep learning, keep growing, stay tuned. Bye.